Hello and welcome back. This video will continue on with section 1.2 and we'll be looking at solving more equations, but now we'll be looking at solving rational equations, or equations with rational expressions in them. Rational meaning we've got polynomials divided by polynomials. So again, because we have fractions here, I want to get rid of fractions as much as possible. So I want to use the same trick in the last video, and I want to multiply by the least common denominator. So I have to look at all these denominators, and I need to factor them. So what are the factors of 2x? Well, it's 2 times x. What are the factors of 18? 18 is 2 times 9, and 9 is 3 times 3. The last fraction over here is 3x. So 3 and x are the two factors. So we need a factor of 2, a factor of x, and 2 factors of 3, in fact. So we need 2 times 3 times 3 times x, and each one of these will go into that. So this happens to be 2 times 3 times 3 is 18x. So I'm going to take both sides and multiply them by 18x. And this will simplify nicely. On the left-hand side, 18x times 5 over 2x, the x's will cancel, and then with the 18 and the 2, we'll only have 9 left over. So on the left-hand side, I have 9 times 5, which is 45. On the right-hand side, I'm going to distribute the 18x first. So 18x times 17 over 18 minus 18x times 1 over 3x. Again, 18x times 17 over 18. 18 and 18 will cancel, so I'm left with 17 times x. And then over here, the x's will cancel, and 18 divided by 3 will be 6. So I will add 6 to both sides of my expression, or both sides of my equation, excuse me. And the reason that I will add 6 to both sides is I will cancel out the 6's there, and I'll be left with just 17x on the right-hand side. So I only have x's on the right-hand side. Left-hand side, I'll have 51, and when I divide both sides by 17, I will be left with 3 is equal to x. And now that we have our solution, so our solution set is only the number 3, if I come back and plug this in, I should get exactly the correct, I should get a true statement. So let's plug this in. Wall this section off. So I'll have 5 divided by 2 times 3 is equal to 17/18 minus 1 over 3 times 3. So let's simplify a little bit. 5, this will be 5/6 is equal to 17/18 minus 1/9. Here, I'm going to put everything over least common denominator again. Very quickly, the least common denominator will be 18 here. So let's multiply the top and the bottom of this fraction by 3 to get 15/18. 17/18. And 1/9 is the same thing as 2/18, multiplying the top and the bottom by 18. And when I subtract if I take 17/18 and I subtract 2/18, I do in fact get 15/18. So everything works. Let's try one more, more or less straightforward one. I need to do that. So again, I have fractions. I want to multiply by the least common denominator, the lowest common denominator. So here are my 3 fractions. X minus 2 can't be factored anymore, so that's got to be 1 factor. X minus 2 can't be factored anymore, and 3 can't be factored anymore. So my least common denominator is going to be 3 times x minus 2. I'm not going to expand this because some of these factors will cancel. So, show you what I mean, let's multiply both sides by 3 times x minus 2. 3 times x minus 2 times everything. Whatever you do to one side, you have to do to the other side, and if you're going to multiply something by a number, you've got to multiply the entire side. So this is why I put the entire right-hand side in parentheses. So here, you can see that the x minus 2 that I'm multiplying by will cancel out with the x minus 2 on the bottom of the fraction. So I'm left with 3x. Over here, I'll need to distribute 3 times x minus 2 times 2 over x minus 2. See some things canceling there. And then 3 times x minus 2 times 2/3. So x minus 2 and the x minus 2, these will cancel. And I'm left with the 3 times the 2, which is a 6. And I'm going to be subtracting everything over here. The 3 and the 3 cancel. So I'm left with 2 times x minus 2. And from here, this will be a lot simpler. So simplifying this left-hand side, 6 minus 2 times x is minus 2x. Minus 2 times minus 2, that will be plus 4. So we have 3x. The 6 and the 4 will add up to 10. We've got minus 2x. From here, I want to get all my x's on one side, so I might as well move this 2x over by adding it to both sides. Why am I adding? So that the negative 2x and the positive 2x will cancel, and I'm left with 5x is equal to 10. Dividing both sides by 5, not 4, I get 2. And again, when we come back up here, we look at our original equation, and we look to see if we can plug 2 in. So let's take 2, and we'll take 2 minus 2 on the bottom. We've got 2 over 2 minus 2, minus 2/3. And immediately we see 2 minus 2, that's 0. So something went wrong, but in fact nothing went wrong. We found what could be the only solution to this. However, I can't plug 2 in here, which is why we need to check. So even though our calculations came out with x is equal to 2, there are no solutions. Again, inside of this expression, I'm dividing by x minus 2. So I can't divide by 0, so I know right away that x cannot be equal to 2. Since x is equal to 2 is the only possible solution, and it's not even possible, there are no solutions. This is okay. Equations can have more than one solution, or no solutions. In this case, there are no solutions. And if we think back to one of our first videos on sets, our solution set is in fact empty. So we have an empty solution set, and the symbol for this is a circle with a line through it. This will show up on the homework. This last question is just another example of how these things might be worded. So this says find all values of x such that we have y1 is equal to this expression in x, y2 is equal to this expression in x, and y1 is equal to y2. So we need to solve for x. And we've got 3 different equations here. But it's not going to be that bad, because we know that y1 has to be equal to y2. y1 is written here in terms of x. y2 is written here in terms of x. So what I'm going to do is I'm going to take this equation, and instead of writing y1 is equal to y2, I'm going to replace y1 with this expression, and I'm going to replace y2 with this expression. y1 is equal to this, so they are the same. y2 is equal to this thing, so I know that these are the same thing, so I can replace it. So we have fractions. We need to multiply by the lowest common denominator. We'll need to factor each of these guys, and this is pretty simple. The way that this question is written, the factors of the first one are x plus 4. Oops, I don't want to write that. The factors of the second one, and then the factors of the third one. This is the difference of squares. So the factors here are x plus 4 and x minus 4. Well, that's convenient because our lowest common denominator is going to be x plus 4 times x minus 4. So x plus 4 times x minus 4 times the entire left-hand side. And this will be equal to, again, whatever we do to one side, we'll have to do to the other. And we are ready to start canceling and solving our equations. So after I distribute, the x plus 4 will cancel on the left for the left one. So this one will cancel with this one, and we're left with x minus 4 times 1. So I've distributed and simplified in one step, and then I can distribute to this other one where this factor will cancel with x minus 4, and what I'm left with is an x plus 4. So I've distributed and canceled in one step here. Next, I know that x squared minus 16 is just x plus 4 times x minus 4. So both of these will cancel with this guy. So cancel, I'm left with 22. This question was written in such a way that everything will cancel very easily. So x minus 4 plus x plus 4, x minus 4 plus x plus 4 is equal to 22. X minus 4, x plus 4, I've got two x's. Minus 4 and plus 4 cancel, and x is going to be 11. So just like in the last question, we should make sure, is this actually a solution? So we should plug this back up in here and see if we get the same thing on both sides. In this particular question, this will be a little bit tedious, so I will simply assure you that this is the case. If I write these things down, we will have 1 over 11 plus 4 plus 1 over 11 minus 4. We would have to simplify this, and then for the other one, we would have to take 22 over 11 squared minus 16, and it will turn out that these two numbers are in fact equal. It just takes a little bit of work. So I'll let you do that on your own, but this is indeed a solution to this question.